can see, and we started recording. Excellent. You might have to hit OK for the recording. Um, the slides that you see in front of you, preparing for heat pump upgrades, I have put a link to those slides in the chat. Is it still there, Kara? Maybe you can put it again. So if you want to, and I'm going to leave that link live for you all for the next week. So anytime in the next week, if you want to go to that link, you can go there now. You can download the slides. You can, screen capture anything on those slides. You can go to the different links as well that are embedded in them. Also, we encourage questions and comments throughout the presentation today. If you want, you can just drop them in the chat box, and Kara's going to monitor the chat for us. So she'll interrupt us whenever. And, especially if we use terminology that you guys aren't familiar with, although I'm so grateful for the introductions. It sounds like there's a ton of expertise on the call today, and I think that is absolutely wonderful. So maybe sometimes you'll be chiming in with your expertise, and we welcome that as well. And also, we're going to leave hopefully at least 10, 15 minutes at the end for just discussion. So we can all come off mic and we can have just a nice roundtable discussion about these things. Anything before I begin? Okay. So let me just advance here. Kara already gave our background, but we're Simbe Homes. We focus on new homes and deep energy retrofits and prioritize wellness, energy efficiency, and technology. The Retrofit Lab is our training arm. It's a part of Simbe Homes. And hopefully someday we've been nurturing it to become its own nonprofit entity that focuses on workforce development. So for our agenda today, we're going to start off with just some basics about heat pumps. We'll probably go through that very quickly because it sounds like everybody's experts on the call. And then we're going to home in on three particular technologies for heat pumps in homes. We're going to talk about different ways that clients come to us looking for these sorts of upgrades. And then we'll shift over to sort of a more building science conversation about looking at the home holistically and what does that mean and what are the different steps that we go through in order to kind of move forward this holistic approach. And then the last third of the session today is going to be three different case studies of projects that we have finished recently. So we have some videos to share and some lessons learned. We really do hope that people learn from our mistakes. We've had some very interesting challenges along the way. We'd like to consider ourselves innovators in the field, which brings up a lot of different challenges, but we've also figured out how ways to overcome them. So that's what we love to share. So we'll go ahead and get started. So this diagram that you see here is, I've looked all over the internet for my favorite diagrams of the heat pump technology, and I think this one is pretty good. So basically, heat pumps have been around for a long time, right? We know like an air conditioner compressor is a heat pump, and those have been around like since the 70s, right, Matt? Even earlier, yeah. Your refrigerator is a heat pump as well as a compressor. So basically what it means is you've got two different coils, a compressor coil and evaporator coil, and you have this liquid refrigerant, this chemical that runs through these coils. And it goes through different phases where it attracts heat from the air and then it moves from a liquid to a gas, and then it releases that heat in another space and then re-liquefies itself. So that's a basic of every sort of heat pump system. The new thing is that now we have this reversing valve, which actually isn't called out in the diagram, unfortunately, but that allows the system to move in the summer where it's bringing heat, taking heat out of your home, and then in the winter, it's taking heat from the outside air and bringing it into your home, right? So that's the basis of a heat pump. And then there are three well, newish technologies that are becoming more popular in homes when it comes to heat pumps: space conditioning, water heating, and clothes drying. And we're going to talk about all three of those today: the pros, the cons, the things to keep into consideration when you're installing these technologies. And I should say too that Matt and I speak from the perspective of builders and consultants. We are not HVAC professionals, so we're not going to get too techie here about like different types of refrigerants or you know, different aspects of charging a refrigerant, for example. We're not installers ourselves. So this is from the perspective of, hey, we're contractors who work with HVAC providers, installers every day, and these are the things that we have learned along the way. In terms of our clients, we kind of put them in three different buckets, and they both have sort of caveats, right? So the first client might be a person who's just looking for equipment replacement, and that's somebody who, you know, maybe their furnace is on at the end of its life, or their water heater is at the end of its life. Um, and you know, maybe they're experiencing some comfort issues, or maybe they're just like interested in electrification. Maybe they're interested in decarbonization because they know it's better for the environment. Some of the challenges around that is that, you know, first of all, these kind of conversions don't necessarily happen very quickly. It takes a lot of planning and there are a lot of different steps involved. And so a lot of times when people come to us and say, well, I want to upgrade to heat pumps, you know, we have to do sort of a reality check with them and say, okay, well, here's the whole program that we're going to talk to you about with your home, and we have to learn a lot about your home. And it's not just as simple as going in and swapping out a piece of equipment and saying, "Oh, you've got a 2 ton. Okay, here's your new 2 ton." It's just not that easy. And hopefully by the end of today's session, you'll see why. Um, and then also, in terms of, well, the other issue is that if the house is not tight as it is, you know, those are things too that we want to address from the get-go, like the envelope, you know, which is going to impact the sizing, which is going to impact the timeline. So the second type of customer, and this is more common for us, is people who are already interested in doing some kind of you know, substantial renovation or addition to their home. You know, maybe they're looking for a new master suite, they're blowing out the back of the house, maybe they're going up or something, or they're just going to gut and completely redo their kitchen. Now, the good things about these situations is, you know, you're getting an opportunity to really get into that house and get behind the walls and learn a lot about the home. The challenges are a lot of times these types of renovations are focused, you know, primarily on aesthetics, design. I mean, they don't necessarily want to think about performance. And we've had a lot of customers just really not be interested in learn, you know, studying the existing structure. They just want to focus on what you're building new, you know. So we try to bring to them this whole house approach. And you know, sometimes that's a not such an easy sell. Um, but the third type of customer, and honestly, in a lot of ways, this is the easiest route we have to take, although not necessarily the most sustainable, but that is to just build new. You know, a new construction from the ground up. You have all new systems. You have the most advanced building techniques. Um, and you have very stringent air tightness standards now in DC and Montgomery County. You have to be under 3 air changes per hour, or three or less, in order to pass the final inspection. So all of that is really going to help make sure that your heat pump equipment performs very, very well. Some of the challenges that we face with new construction, though, is the number one challenge I would say with our clients is that they come to us too late. Like they've already developed the plans, they've got the construction drawings done, maybe they even have a permit in hand, and then they tell us you know, that they want to be super energy efficient and, you know, take advantage of all the latest technologies. And, you know, sometimes it's too late. So we have to get in there early, and we have to sometimes go beyond code, which most people are don't want to put the money there, right? They want to put the money in their fancy countertops or whatever. And so we have to kind of convince them that it's worth the money. So those are the three different kind of clients we see. We really don't work too much with equipment replacement people. They just kind of it doesn't work with our philosophy. But we do a lot of we work with a lot of clients on renovations, additions, and new construction. And our case studies today are going to focus on these two areas. Okay, so I'm going to turn it over to Matt now, and we're going to delve into some stuff about heat pump HVAC.
Yeah, so let's talk about the efficiency first. Heat pumps can be 200 to 300% more efficient than even your high efficiency gas furnaces. And what does that mean? It means that on a heat pump, because it mostly moves heat from one area to another, outdoors to indoors, indoors to outdoors, it uses 1 unit of electricity to move 3 units of heat. So that's where the efficiency comes from. Whereas a high efficiency gas furnace will only burn 95 to 98% of the fuel that it's provided to produce the heat. So that's where the efficiency comes from. And we'll get into a little more about the conversion from kilowatts to BTUs a little later. Um, there's a variety of heat pumps that we use, and in our last project, we actually used all three types that we're describing here. But you have your standard ducted air handler, which attaches to duct the same as your old systems. And then you have ducted mini splits, and then you have ductless mini splits. And we'll go to the next slide, and I'll show you an example of each, how we use them. This is our latest project. So on the left side, the two-story part is our existing house. It was a 1952 Rambler, which had a gas furnace that was ducted. So we used our heat pump air handler there and connected to our existing duct, which we modified because the ductwork was, decades old, and the setup was not how, our modern technology tells us to do
By
it.
yeah, and by modified he means we tore it all out and
Yeah.
redid it. It's like a
But we
complete.
did remain, we did keep the bulkhead in the basement.
Oh yeah.
And um, so that's how we address that. So that is one zone, is a two-story, part of the original house. And then on the first and second floor of the addition, we used the wall-mounted mini splits, ductless, and those areas are roughly 15 by 30. So we were able to just use 1 unit on each end. And if you look over my shoulder, you can see the one that we have for this level. And we're in the great room. And then on the third floor, we use the ducted mini split because we have a bedroom, a bathroom, a closet, and an office. And we have a small attic space. You can see where the unit is, which makes those units very easy to install. And we were able to duct that and provide enough heat and cooling for that whole upstairs. On the ducted mini splits, you want to make sure that you have access. They can fit in small spaces, but you want to have access to service and clean coils and make sure you have all that covered. So next, we're going to talk about the space considerations for your units, indoors and outdoors. Um, you want it all. You want if possible, to have all of your equipment and ductwork on the interior of your envelope in a conditioned space. Sometimes that's not possible, of course. So you want to make sure that the space your duct is in and your units are in is properly ventilated, insulated, and your ductwork and unit are insulated very well. Excuse me. Now, you also want to make sure on the outdoor units, it's recommended that you have some kind of cover over your unit to get optimum performance. It's not necessary, but whenever possible, it's good to have an overhead cover for your outdoor units. And you want to make sure that you look at the codes because there's setbacks on outdoor units. So you don't want to be too close to the property line and have an issue there. And then you just want to make sure that you plan for your line set and your condensation drain exits and entrances to make sure all that works in the best way possible with the conditions you're under. And then lastly, you want to check out your electrical panels first. As you size your equipment, generally you're going to need a 200 amp service. Some of these older houses, you're going to obviously need to heavy up. Your outdoor units on heat pumps can run 20 to 30 amps. Electric backup heat can run 40 to 50 amps. So you want to make sure that your electrical panel can handle all the needs of your equipment. So that's might require to get a licensed electrician to upgrade panel.
Mm-hmm. In terms of sizing, and we're going to talk about this in a few minutes, you want to make sure that you have a decent set of mechanical design documents, a JD and S. And really, we've found that it's important to be able to kind of scrutinize those documents a little bit. We get so many of them that you don't really understand at all the assumptions that they've made. They don't seem to make any sense. Actually, they maybe just Xerox the one that they used at the last house and change the address at the top. Honestly, that does happen in our business. So you want a really good set of load calculations. You want to make sure you have proper duct sizing and layout, and make sure that your equipment is sized correctly. In terms of installer expertise, I cannot tell you how important it is that you work with people who really know their equipment, and preferably they have some kind of certification from that manufacturer. We've tried on our last project actually to get people to use equipment from a manufacturer that they're not familiar with, and it's been really difficult. And a huge learning curve. So don't assume just because somebody's installed a heat pump that they can, they can do a Daikin if they've been doing Mitsubishi, for example, or GE or whatever. Also, as a bonus, if they have the Energy Star credential and they know, then they really know their stuff in terms of filling out all the paperwork and all of, the formulas and that go along with it. And maybe they have a certification from an national organization like ACA or Advanced Energy. That's great too. Testing is very important. I would make sure that that's part of your scope of work, that you're doing testing pre-drywall, yes, please, for the duct testing right before they seal up the walls. So you know if there are any problems and you can address those issues, but also testing to make sure that the rooms are well balanced, and static pressure testing on the equipment as well. Advanced controls are important. Having smart thermostats are ideal, but we know that things like Nest and Ecobee tend to dumb down the equipment. It depends on the manufacturer, of course. So you need to, a lot of times it makes sense to work with the thermostat that is the same manufacturer as the equipment itself to make sure that you're getting all of the functionality. And then comes the really fun part when you're trying to integrate a whole bunch of other equipment like humidifiers and dehumidifiers and ERVs. And we've written articles on that. If you're interested, I can send you the links because it's not totally prescribed. There's no roadmap necessarily for this stuff. If you have, for example, an April Air dehumidifier, they haven't necessarily talked to Mitsubishi about how their equipment is going to work together. And so you've got to kind of plan all that out and make sure that's all part of your budget as well. We've done these projects where at the very end we say, oh, wait, now we need a whole house dehumidifier, and we're going to put one on the system down here and one on the system up here. And and not really thinking through like just everything involved in adding that piece of equipment. It's quite involved. Um, and then, of course, there's the issue of use and maintenance. There is a very, for some homeowners, there's a learning curve. I mean, they don't necessarily understand why is the fan always running, right? A lot of this equipment is set to continuous fan, and it's set for a reason, right? Maybe that fan is what's reading the temperature, and and making sure you're at the right set point. Also, old furnaces that were heated with gas, the air can be really hot coming out of the register, right? Up to 140 degrees or something like that. And it's different with heat pumps. Like the temperature of the air might be 85 degrees, a big difference, but it's going to run longer and it's going to thermally wash not just the air, but the surfaces of the home too. So ultimately, you're going to be more comfortable, but that leads to the other part of the education, which is that we keep the thermostats within a very narrow range, right? We go 2 degrees up or 2 degrees down, depending on the time of day or your needs or whatever, but we don't necessarily change them very much in that narrow range. And then the last thing that we want to make sure the homeowners are very aware of is the issue of maintenance for the filters. They should be cleaned, and the units, especially the mini splits, should be vacuumed at least once a month. The thing about the mini split is because it's a small unit and the air is running through it fairly quickly, it doesn't necessarily have time to dry out as much as other equipment might. And so you get a lot of moisture buildup in there. And so, again, that goes back to having a dehumidifier in the home, making sure the humidity level in the home itself is appropriate. But also, it's a good idea to make sure you do a deep clean, and that's when you take the entire mini split unit apart, take it all apart, all the components apart. This is something usually that a professional needs to do. Um, and it can take several hours, but that's when you get every bit of the components like super clean. There might be a little mold or mildew building up in there over time, so you want to make sure you do that deep clean. And we have seen that, and we've had customers too that have complained of like a mildew smell coming out of their mini split unit. And that's usually a sign that it needs that deep clean. So I'm going to pause for just 1 second here, and before we go on to water heaters, and just see, Kara, are there any questions, or does anybody?
Nothing in the chat
Okay.
yet. Oh,
All right. Well, great. So we'll move on to water heaters. Um, so a few things to think about with the water heaters. I mean, one is I'm going to show you a graph in the next slide, but they're super more efficient than your standard electric resistance uh, tank water heater. And but they do need a certain amount of air, just regular airflow to pull that heat, that energy out of the air and into your water, right? So they say they don't recommend putting them in super tiny closets. I mean, if you do, you have to have a louvered door. And also, they're taller a lot of times than your standard water heaters. So you just want to make sure you look at all of those manufacturer specifications before making the swap. And then the other issue that we have a lot is that they will chill the room that they're in. So in the winter time, basements are already maybe a little chilly. And so what you have is, your HVAC system kind of fighting a little bit with your water heater because their water heater just like wants more and more and more of that air, that heat in the air. So what we have done in the past is we will duct them so that at least, I mean, you can, for example, you can duct the intake all the way from the attic space where it's nice and toasty warm and it's pulling, heat from there. You can also duct the exhaust to the outside in the winter time so that the cool air, goes outside instead of in the room and chills the room. And the other thing is that they can be noisy to operate. And I've had manufacturers tell me, "Oh no, we fixed that problem." And then you plug them in and they're noisy to operate. Like I honestly don't know, and I'm curious if anybody on the call here has installed a heat pump hot water heater that's actually really, really quiet. And I've noticed too that as the room gets chillier and the heat pump is trying harder and harder to extract energy, it seems like the noise kind of grows a little bit. So you just want to make sure you don't put them next to like somebody's bedroom, for example, because that noise that can travel. And here's that graph that I was talking about. So this is a really interesting part of our case studies. At the Queen of Zero, one of the projects we're going to talk about in a little bit, um, we this is a brand new home, a Victorian home that we built. And when the homeowner moved in, our heat pump hot water heater wasn't available yet. It was actually being a new manufacturer, GE's new version of the GeoSpring heat pump hot water heater, and it was delayed. And so we instead installed a electric resistance water heater. And this energy here you see is what the electric resistance water heater was taking. And then no change in behavior, no change in, the house is exactly the same as it was before, same number of occupants. All of a sudden you install the heat pump and the energy goes way down, 75% on average, reduction in energy use from electric resistance to heat pump. And also, we've noticed too here at our current project, the Retro Rambler, which is another case study we'll be discussing, we're using even, he's averaging at the Queen of Zero about 5 kWh per day. We're down to about 2.5 kWh per day. So, and we think the difference between the two houses has to do with our heat pump washer dryer. So that's all really good news from the energy conservation perspective. And they work great. I should say, you're not sacrificing anything in terms of performance. We get plenty of hot water here throughout the house. We've never had a problem. Which brings us to the heat pump clothes dryers. They're about 50% more efficient than a typical clothes dryer from an energy perspective. It's great. You only need a 120 volt outlet, 15 amp circuit. And we've been using this combo washer dryer from GE. It does not require venting, which is wonderful. So you can, if you're moving equipment around, you have a new place for laundry, you don't have to run the exhaust vent outside. They can be really heavy though. You think, oh, you're getting this nice compact thing that can go anywhere, but I mean, it weighs as much as a refrigerator or more. And generally speaking, they do have a little bit less capacity. They've gotten a lot better in this area, but we found that, when you start to put bulky bedding or something in it, for example, it just doesn't come out as nice, as, when you do like more of a normal load of laundry. Is there anything else we want to say about the washer dryer, Matt?
No, it doesn't seem to introduce any humidity into the house either, which is a really good thing.
Mm-hmm. Right. Like your typical laundry room
Yeah.
doesn't do that. Yeah. Yeah, we've been really happy with it. I mean, the other thing that's nice about it is you preload the soap, the laundry soap and the softener. And so, it's like there's so little you have to do. You just come in, you throw your clothes in there, you turn it on, it washes them, it dries them. It talks to my app, my phone. It gives me a little notification when my laundry's done. It's pretty nice and it's time saving too.
See, Joanna has her hand up.
Yes.
Yeah, I have a question. When you say it's 50% more efficient than a electric clothes dryer, if it's washing and drying, I guess that would make it, you can add in the efficiency of the washer as well.
Yeah, no, that's a really good question. I haven't been able to find data on that, but I'm just looking. So I want to know,
Hmm.
yeah, overall, and I think it's saving a lot of water too. So I want to know the conservation on the water. Um, but yeah, I think overall, I guess we could do that. I should mention that we have a SPAN smart panel, which tracks electricity throughout the home. And that's why we're able to, and we're going to share with you a lot more graphs on energy use of this home. And that we have the same thing at Queen of Zero. So we've been able to pull data from and it tells you every single circuit, your washer, your dryer, your heat pump, whatever. And we can look at day, month, year, um, energy usage, which has been really
Uh-huh.
helpful. And so as we develop more of that information in those reports, we'll definitely be sharing them online.
Great, thank you.
Okay, so now we're going to switch gears a little bit. So we've talked about the three main technologies that we've been introducing into homes, and now we want to just kind of just talk in general about our holistic approach or the whole house approach. Really understanding that the house is a system. If you change one aspect of your home, for example, if you change from a gas furnace to an electric heat pump, it's going to impact other areas of your home as well. And so we like to focus on, the issues of safety, comfort, wellness, technology, and efficiency. And we do believe that in order to get the most out of your heat pump technology, you should be looking at the entire home, especially issues of the envelope, air leakage, insulation, indoor air quality, very important to consider as you're making these kinds of upgrades. And understanding different aspects of building science, like, just the stack effect, which is what you're seeing here, right? Stack effect, cool air coming in through leaks in the foundation and pushing conditioned warm air out the attic space. Um, and then really understanding, if you have a moisture problem, where is it coming from? What is the source, and how can you address that? So with our clients, we have kind of a step-by-step process that we look at. And I've broken it down in here to 7 different areas. One is kind of, and we're gonna drill down into some of these. Um, One is to start with a baseline energy audit, or if it's a new home with an energy model, right? And so we really have this data and this big picture of everything that's going on in the home. Number two is to first and foremost always address any kind of self-safety and health-related issues. If there's carbon monoxide in the home, you have combustible appliances, you really want to understand, like, how it doesn't need to be remediated first and foremost. Also looking at the renewable energy potential. That's really good to know as you start to electrify things. Are you going to be able to offset some of that electricity with solar production, for example? Making sure, number four, that you have a very solid set of mechanical design documents. I mentioned that before. We're going to go back to it in a second. Um, Number five, of course, is the envelope upgrades, walls, roof, foundation, windows, exterior doors. Number six is to make sure if you are tightening up the house, then, what is the ventilation needs of that home? Is it being properly ventilated? Are you getting enough fresh air? And then number seven is testing, retesting, and doing all the diagnostics you need to do to make sure that you've achieved your outcomes. And testing at multiple time points along the way. We do baseline, but then during construction and post construction as well. So, real quick, I think a lot of people on the call already have a lot of expertise in this area, so we don't, necessarily won't need to go into detail, but making sure you have a very good energy audit done before pre-construction, super important. And, of course, the audits, I've sat in on dozens of audits now. I've done audits myself. They all are a little bit different. Like some might do the duct testing, but some might not include duct testing. But in general, you want to make sure that you know, basically there's been a good visual top to bottom of the entire house. You want to make sure you've done a blower door test to see how leaky the house is. Hopefully that's been paired with an infrared camera to know where those leaks are coming from. We also do smoke testing as well to identify different leaks. I have here, and if you guys have, if you look up a copy of the slides, there is a sample. We work a lot with Kelly Green Energy Raters. We partner with her to do different kinds of energy audits. She just retired though, so we're happy for her, but it's sad too. This is a project that we worked on. Let's see, I think the date's here. Back in 2023, we found the house was 9.5 air changes per hour. We actually brought this down to like 1 air change per hour. We did aero barrier on this house in addition to a lot of other upgrades. Um, but this is what you're going to see in your energy audit. You're going to see, some observations about the house. You're going to see photographs of the equipment and different air sealing opportunities. And hopefully you've gotten these thermal images as well, which give you a really good idea of where, some of that air is coming from. This house has been put under negative pressure with a blower door. It's cold outside. And we're observing here where all that cold air is coming in around the home. And then perhaps most importantly is have a list of recommendations, right? And you go through different areas of the home and you make recommendations for where improvements can be made. And that's the basis of the energy audit. It's great when they include the duct testing as well, as I mentioned. And then, of course, testing of the mechanical equipment, combustion testing to make sure that any combustion appliances are working appropriately, that you're not having gas leaking or carbon monoxide leaking. And this becomes like part of our roadmap for working with our clients. We go back to this document over and over and over again and make sure that we're addressing these issues. The other thing we've mentioned is doing an energy model. Now you can do this energy model on an existing home, but it's more common with new homes. We've done both. We've done energy models with existing homes. And this one right here is a HERS model. So that's the home energy rating system. And if I'm sure probably most people are familiar with HERS, the lower the number, the more efficient the home. A reference home, a standard home, a code-built home, it's supposed to be is around 100. As you get more and more efficient, actually code now is probably more like a, 70 or 80. You go below 50 if you're doing a zero energy ready home. You're usually at like maybe a 49 at the max. And then when you add your solar energy in, you can go even lower than that. This home, this is Queen of Zero actually, and this is the projected score. So I think the actual final score is going to be quite a bit lower than that. We should be close to zero. Um, and we'll talk about that when we talk about the case study. But this just gives you an idea of everything that goes into the energy model. So it's you're going to include the building, the number of bedrooms, the number of floors, even the number of occupants, the orientation towards the sun, what the R value of every wall of the foundation, the framing, et cetera, et cetera. And this kind of just goes on and on. And you guys all have this link now. So if you're curious, all the little bits of information, the type of lighting that's being used, It all goes into this model, which then creates the score, the HERS score, relative to, other homes in the neighborhood. How energy efficient are you doing? And then they try to translate that into a number, a dollar value in terms of savings. And I find these numbers to be very low compared to what they're actually saving. So it'll be interesting because we will very soon, we will have a number for Queen of Zero, and we'll see if this was of spot on or not. But he's paying like on average like $40 a month in utilities for a 44,000 square foot home. So really, really good outcome there. I mean, the 40 bucks too is a lot of it is just connectivity charges. It's not usage charges because they have, you know, the Pepco has a base charge just to be part of the grid, and Washington Gas has a base charge just to be part of Washington Gas. So.
Nicole, there are a few items in the chat, and then Joanna has her hand raised if you wanna.
Great. Yeah, let's go ahead.
I just had my hand raised because of the questions in the chat. So I don't have any additional questions. And you already answered mine about sharing the sample. You are going to share the link, right?
Share the link. Yes, you have the link to the slides.
Yeah.
Yeah.
Okay. Thank you. And then there's another question.
And then Christy asked, I thought Aero Barrier was best on new construction. So I think.
Oh, yeah, because we used it at a remodel. You can do both, right? So AirBear is good for new construction. But this particular home, we had basically um demoed every exterior wall in that house to improve air sealing and insulation. So the furniture had been moved out. We were already planning to paint the home because it's sticky and it gets on stuff, right? And so you don't necessarily want to do it in a home where, yeah, there's furniture, there's carpeting, because it can get on the walls and then you have to repaint the walls. But it is doable, and it's recommended, I think usually after drywall is installed. And so then it's just trying to follow the teeniest, tiniest little cracks and crevices. Does that answer the question, I think?
Can I ask a quick question? How is that different from the infrared? That also shows where cold spots are, right?
Oh, right. So infrared is more just a diagnostic tool. It's going to tell you where the problems are, whereas AeroBarrier is an actual aerosolized, I don't know if I said that right, chemical. It's a non-toxic, Green Guard, whatever chemical, but it floats, it
Okay.
flies through the air and it fills the hole.
Okay. Okay. Thank you.
Okay, great. So moving on, I'm going to go back to our slide presentation, and I'm going to turn it over to Matt now. He's going to talk about some common problems that we find in these older homes.
Yeah, these are very important things that you want to address, especially when you're going from if somebody's converting a gas furnace to a heat pump. And the reason being is because a gas furnace can mask a lot of these problems by, like Nicole said, pumping 130-degree heat into the house, and then you drop down to an 85, 95-degree heat. These air leaks and such are going to be more pronounced, and you won't get the comfort that you want to give to your customers. So these things really should be addressed when you put your new equipment in to get the maximum performance and most comfort for your customer. The first is air leakage. Obviously, we want to, crawl spaces, basements. We want to make sure windows are airtight. The stack effect is very critical, where you can, the first thing you want to do is seal the crawl space basement, and then the ceiling of your envelope, so the drywall at the top of the second floor by, you know, sealing around lights and smoke detectors and registers if you have them, and that'll keep that air from just, you know, pumping through the house. Moisture and humidity, that's gonna, you know, create, you know, high humidity in your house. So you want to address that. Make sure you don't have water seeping into basements, or make sure that your crawl space has the proper vapor barrier and taped and sealed to the foundation to keep that moisture and humidity out of the house. Equipment sizing, you know, back in the day, a lot of this was drawn on a napkin. You know, they took the square footage of the house, and that's how they got their duct size. They generally oversize their equipment. So when you're replacing equipment, obviously you're going to do your, you know, manual J's and your, you know, house study and properly size that equipment. And when you do, you want to make sure that the ductwork, if you're using the existing ductwork, that ductwork is sized as well, because you're going to lose or gain static pressure, and that equipment is not going to work the way you want it to. And then there's a duct sealing,
AeroSeal.
AeroSeal is a very good duct sealing system, and that they can, when you get the old unit out, you can seal that duct and then put your new unit in to get your duct sealing done. Pests and toxins, you know, again, that air sealing from the outside to the inside will keep, you know, your pests out, and, you know, any toxins on the exterior of the house, you want to keep that, you know, from being sucked in that, you know, stack effect. Duct leakage, you want to check that, and the AeroSeal will take care of that. And then the thermal transfer, you know, mostly basements, but you want to make sure your envelope is, you know, is insulated, you know, to the best it can be, especially crawl spaces. You want to make sure if your equipment's in a crawl space, you want to insulate the exterior walls of the crawl space, or the main floor of the house there. And then the next slide just kind of shows you where the, you know, main heat losses are in a house. You know, again, going back to the stack effect and trying to stop that air from coming up through the house and out the roof. You know, if you take the foundation ceiling and the attic ceiling, you know, that's 40 to 50% of all your heat loss there. So that can help with comfort a lot. 35% of walls, you know, that's where, you know, you want to try your best to seal what you can. If your customer is redoing their siding, that's the perfect time to do the air seal on the walls and windows, and doors. So, you know, you want to keep that in mind. Also, one thing to look out for when you are doing air stopping, like Nicole said, that everything you do is going to change something else in the house. So we did an air stop on one of our projects, and it's a, you know, 150-year-old Victorian, and we just air stopped basically the crawl space in the attic, and even the old windows, the original windows are still in it, and they're leaky. But just by sealing the attic and the crawl space, we discovered that there was a leak in the dryer gas hose that we didn't know was there until we sealed it. So when you start sealing things up. You really have to pay attention and be aware of everything else in the house. Like if you have gas appliances, you know, make sure that you're not creating another problem by fixing a problem. So that was the lesson we learned, and it was pretty amazing. The house was so leaky, you couldn't smell the gas, and then when we sealed it, the whole first floor smelled like gas. So you want to keep an eye on that kind of stuff.
Yeah, we'll talk about that more too when we get into the case studies. Um, we mentioned the mechanical design documents a couple of times. It's interesting because, when I first started out in this business, I would just rely on the HVAC guide to have a really great set. I wouldn't even necessarily read them, but I've found over time that a lot of times that they're making assumptions that are not accurate. So I've had to kind of educate myself a bit. But, so the manual J, I think everybody knows that's your load calculation that tells you the size of the equipment that you need. Manual S is going to be the specifications of the equipment itself. How do they match up with the manual J? And then the manual D is going to be a diagram of all of your duct work and all the different registers, the supplies, the returns. Should show you how the system is balanced. There's a link here to ACCA is the organization that publishes all of the rules and all the information about the manual J, the manual S, the manual D. They have some really interesting documents here for just people who want to kind of scrutinize those documents. And I also put a sample from the Queen of Zero up here as well, if you want to look at a sample. This is from RightSoft, is a popular software that people use to input the data. But basically, you can go through here and look, and we don't have a ton of time today to kind of go through all of the details in these reports. But basically what you want to be looking for, it's one of the first things I try to look at is to see if these square footage numbers make sense. This is broken up into different systems. We have in the Queen of Zero, we have 4 separate HVAC systems. So each system is serving a certain number of rooms. You want to check and make sure that square footage area definitely makes sense. You want to look at what assumptions they're making in terms of design temperatures, those sorts of things. And if you're in a program like we do, Zero Energy Ready Homes, which now has changed names, Joanna probably knows what it's called. But that will actually, like an Energy Star project, it'll give you specific design temperatures for your exact area, geographic location that you're supposed to be using in these models. So that's one of the things that I like to check as well. And then basically when you go down to here, after that, you're going to get into, this is the actual duct design. So this is your manual D. It shows the layout of each floor and where these duct runs are going. And it shows you CFMs per these different registers. First floor, second floor. And then after that, you'll get into the manual S, which is the actual specifications of the piece of equipment, the model number, and those sorts of things. So again, this is just a very, very quick overview of the documents, but I mean, I think it does help to take the time and really have your HVAC person go through it with you as well, so they can show you the assumptions that they've made and why they've made those assumptions. Okay, so now we're going to switch. If there are no questions, Kara, we'll go into our case studies. I think we're running on time too, which is excellent.
Joanna said it's called Efficient New Homes.
Oh, the Efficient New Homes Program, ENP. No, ENHP. Okay, thank you. Um, So our first case study we've mentioned a few times now. This is the regeneration house. And this is a picture. This is from the early 20th century, but it was actually built in the 19th century. So it had already been around for maybe 20, 30 years. We don't know when this picture was taken. Originally, when we purchased the home, it was 1,440 square feet on these two levels, and then we added an in-law suite addition. And we electrified the HVAC, but very interestingly here, we did not 100% remove the gas. And in some cases, this actually makes a lot of sense, especially in cold climates. So we kept a gas furnace in the cellar, and we have found that it's actually very helpful for this older home to have a little bit of gas on the coldest days. When the heat pump, when temperatures go down below freezing, even if you have a cold climate heat pump, it will sometimes start to struggle to pull that heat out of the air, the absolutely freezing air. They're supposed to function to a pretty high level, up to -5 degrees or sometimes -13 degrees outside. But we've noticed when it gets down into the low 30s, into the 20s, it struggles a little bit. And so we kept a gas boiler operating in the basement with one radiator in the basement. And this is rental property of ours. They will crank it up a bit when it gets really cold outside. So it's a good to have as a backup. We did a lot of we completely updated the interior of this home, and also did I think I mentioned the in-law suite addition. And we were able to, just by sealing the attic space in the cellar, we were able to reduce air infiltration by 50%. So we went to 18 to 9. 9 is still pretty high, but for a 1890 Victorian, we think that's pretty good for now. The next task we have will be to refurbish all of the windows. So it's a historic designated home. We can't swap out the windows necessarily. I mean, not easily anyway. So, but what we can do is remove them. And Matt, what can you explain the process for refurbishing the windows?
Yeah, so there's a few companies that specialize in restoring historic windows. So they'll come in, they'll take the sashes out, and they'll reglaze them, finish the frames. They'll put new seals on them. Well, put seals on them because they originally did not have seals. So yeah, so they basically remodel them and make them airtight. And yeah, and then we should do much better on our blower door tests because they are all original windows.
Sometimes you have to phase these things in terms of time and budget. Yes, Kara, did you have a?
Yeah, Joanna had a question about heat pumps that are especially efficient in really cold temperatures.
Yeah, so well, I mean, they're called cold climate heat pumps, and most manufacturers are now have a version of the cold climate heat pump, and it really just depends on which manufacturer, which piece of equipment you're working with, but they claim to have efficiency of up to like maybe 100% down to a certain negative degree.
But the one that you installed is not one of those. So you could have, if it'd been a colder climate, you could have gotten.
They actually are cold climate heat pumps. But because the heat pumps will start to struggle, right? They go from like 250% efficiency, 300% efficiency down to 100% efficiency, right? So they're not working as good as they did above 32 degrees.
Mm-hmm.
And because they're struggling a little bit, and because in this Victorian, we still haven't sealed up. We didn't do any drill and fill in the walls. We haven't refurbished the windows. It can get a little drafty in there.
Mm-hmm.
So for those renters, we like to have a little bit of backup gas heat for them. You could also have an electric resistance strip, but we have a story about that coming up.
Okay.
Yeah, because
Thank you.
they're big energy hogs. Yeah.
Mhm.
Okay, so I'm just gonna show a little video here and we'll just talk a little bit more. So it's just like a couple minutes. So you can see the transformation here. Is everybody seeing the video now, Kara? Are you seeing it? Yeah. Okay. So this is what it looked like originally when we purchased the house in 2021, something like that. I think we finished the project in 2023. And oh, it's got a sister house right next door. They're identical. We started by working on the exterior. It needed a lot of work. It needed a lot of love, but we kept all the old original siding and just refurbished it. We put a bonding primer on the outside. We didn't scrape it all off because it's lead-based paint and we didn't want to expose anybody to that toxin. So we went through the whole process of repainting the exterior of the home. And once that was done, then we built this new structure on the back. I think that's where it's going next, which is one.
And I just wanted to point out, just by using we used a bonded primer, which actually has a density to it. So as we primed it, it actually filled the gaps in this is real wood lap siding, so, or shiplap siding. So it actually sealed the siding, which helps with our air seal. And which is very important because this house, has no insulation in the walls.
Yeah, and then here's a picture of the structure that we added on the back. So this is an ADU. It's a one bedroom, one full bath, completely age in place, universally designed. There was actually an older couple that we purchased the Victorian from. They wanted to stay in the neighborhood that they love, so we built them this rental apartment and gave them a lease in perpetuity. So they have a place to be, and it's completely safe for them too because it's all on one level. Here we go. And now we're going to show you. This is us building the foundation. This is something we do now. We're insulating the entire foundation. Underneath all of this is insulation. Here's the framing. It was just a conventional 2x6 framing on the exterior walls. But then we went beyond code on the insulation values. I forget what we had in the walls, R23, I think it was. Oh, we did the continuous exterior insulation. So that's a big thing now to make sure that the house is really, really well insulated. Here's Matt doing an star job on the windows. And then, so in addition to the exterior insulation, rigid, we did cellulose spray applied on the interior. We put baffles in. So this is something that we do now is we have an air channel underneath the roof sheathing, but then we put baffles in, then we seal those up, and then we insulate on top of that. So we have both ventilation going on, and we have a completely encapsulated space. That was them doing the drill, the fill on the well, I guess we call it the dense pack on the cellulose in this house. And this is where they're just finishing up. And that's what the new apartment looks like. It's really beautiful, vaulted ceilings. We did plywood on the ceilings. Just a really gorgeous space, plenty of natural light.
And we did stop right there. There's a floor mounted,
Oh, right here.
yeah, behind the chair, there's a floor mounted
You can't see
mini
it.
split there.
Yeah, you can't see it, but we'll show you in the other space. So that's what it looks like when it's attached to the old Victorian. We put on this massive solar array so that that whole apartment is now net positive, actually. It's all electric net positive apartment. And here's us doing some changes to the interior structure. We tried to keep some of the original detail. This is what we were talking about before. When you have to have a piece of equipment in in a vented attic space, an unconditioned vented attic space, that's what we had to do here. We created a little catwalk and a little raised platform so that you can insulate completely underneath this, but also put your equipment into that space as well. It just creates a nice, well insulated, you're basically creating a great barrier between this attic and the rest of the house. And we try to keep, I think it's important when you're doing heat pump upgrades to try to save money wherever you can. So this is just an illustration of where we kept all the old cabinets and we painted them and, saved quite a bit of money in the kitchen, which it turned out really nice. I think that's the end of this video. It's just showing you what happened in the old Victorian. Oh, there's what I'm going to show you the floor mounted mini split. So there used to be radiators here, right? So we took the radiators out and we put the floor mounted mini splits in, and the space was already there, so that worked out really well for that transition. And there's another one. There's two on this floor. There's one back there. You can see in the rear. Okay. So I think that is the end of our first case study. Matt, do you want to just talk any other lessons learned here? Did you tell the yeah, we talked about the gas. Okay.
Yeah, this was a project where we sealed the crawl space in the attic and discovered we had a gas
leak.
Yeah.
Yeah, it filled up the first floor of this house really smelled weird. And we brought the gas detector in and just went crazy on us. So we're like, oh, there you go. Yeah, but this was a very successful project and everybody's really happy here too. The next case study that we have is the Queen of Zero project. This is a Queen Anne Victorian, 4,800 square feet, built from the ground up. And we built it with SIPS construction and Tesla solar roof and Powerwall backup batteries. Um, Matt, I want to show the video, and do you want to just narrate for them and tell them about this was Zero Energy? Oh, it's the new, I don't know the new name again. Energy Efficient Homes, New Homes Program, certified. And, this is the one I was saying where, it's this humongous house, but he has basically no utility bills. It's like $40 a month after you take in the solar, the SREC credits that he receives. So I'm going to play this video now, and Matt can tell you a little bit more about the special features of this home. Make sure it's muted. Okay, go ahead, Matt.
Yeah, so this is a house that Nicole was the energy consultant on. It was a house that had caught on fire, old Victorian, 150-year-old Victorian that caught on fire, and the homeowner really wanted to rebuild it in the same manner, even grander than it was. So you just saw a clip where we insulated the whole basement slab. The code only requires for a certain amount of insulation where, the grade would be less than 2 feet, but it makes a very big difference to insulate the whole slab underneath to give it that thermal break between the ground.
Just realized we're behind time right now, so I'm gonna go a little faster.
Yeah, so we went above and beyond the normal code requirements on insulation. There's our Mitsubishi equipment for that's a high efficiency heat pump. We had Aprilaire, we had humidifiers, dehumidifiers, ERVs, that all needed to be connected together and work properly, which it takes time and some experimenting, obviously. And then you saw the Tesla roof guys. All zero VOC. Again, it's a very tight house, so zero VOC paints, flooring stains, to keep the indoor air quality at its best.
Okay, I'm going to stop there. It keeps going on about the sponsors, but we don't really have time for that.
And just give a quick overview of this. Oh, you got charts to go through?
Yeah, the charts. I want to get to my charts.
You should just go straight to graphs.
Okay, we'll go straight to graphs. Oh, we don't get to watch the movie. So, okay, this is our third, and I want to save time for questions. So this is our third case study. This is the Retro Rambler project. It's where Matt and I are right now. We just finished this project. It was a 1952 Rambler, and we've more than doubled the square footage, and we completely electrified it. We got rid of all of the gas, and this had gas galore. It was a gas furnace, a gas dryer, a gas water heater, and a gas cooking range oven. Everything was gas. And we added an EV charger. We have the smart span panel, and we are following the zero energy, the new program's rules. Even though this is not a new home, we were able to, we actually have our final inspection coming up at the end of January. So hopefully we've hit it all on the mark, but we do believe that we have been able to meet the very stringent requirements of being zero energy ready. And right now our projected HERS score is a 29, which is quite low for a very old house. We've done a blower door test. We were around 3 air changes per hour, but we've done a lot of air sealing since then. So we're looking forward to getting another test done very soon. We do have a video here, but we're running out of time. So I don't know if I can show the video, but let me just show a little bit of the video. How do I make this bigger? Oh, here we go. Okay, so let's see. It starts out like this. That's the original home. Those are pictures of the original home. It was a kit house. So these panels were made in Indiana and they were shipped flat here in the 1950s. And at the time, it was really high tech for what they were doing. And the actual panels on the exterior have held up really well. They had some water damage, like maybe in the last 20 years, but that was because whoever put the vinyl siding on did a really crappy job. So we repaired that, but we kept most of the exterior structure, and then we were able to do exterior insulation while we resided this home. That's when we tore off an old sunroom back there. It was kind of useless. And then you'll see we put on, oh my, there's our dog. Okay, and then we have the new edition coming on here. There's a picture of the new edition, and I'm just gonna fast forward, and we do lots of natural lighting. This is the new master suite. That's the new kitchen. There's a bunch of pictures like this on our website too, if you're curious. Oh, here we are putting this exterior 2.5 inches of Armax 16.7 on the exterior of the original structure. So that's how we air sealed and insulated the original home. Just fast forward, we did blown in spray applied cellulose on the addition space and the inside. We had was it R6 zip sheathing on the exterior of the addition. So beyond code on all of our installation values, which turned out really well. These gorgeous Pella windows, which I love. And there's that span panel I've been talking about. And it shows you all the circuits of the span panel. And they use just normal breakers, which is nice. You can buy them at Home Depot, but then there's a computer inside. And so we can, on our phones, know what every circuit is doing at any time. We can turn any circuit off from our phones as well. There's Matt fixing the exterior sheathing on the old house. Okay, so interestingly, here's how we're going in terms of performance so far. So energy use in 2024 is in the blue versus energy use in 2025 for the whole house. Now, keep in mind, we more than doubled the square footage. And if you add the extra ceiling heights that we have now, it's the volume has more than doubled. But we have been able to lower our overall energy use. Now, interestingly though, the problem is that electricity costs a lot more than gas right now. So even though we've lowered our energy use, and we're pretty proud of that, we had a very large electric bill in December. And so we went into the data to figure out what was going on. So let me just show you a little bit about the data. So here is a graph of the temperature outside. That's what this bar is down here, and the amount of energy that all of our heat pumps are using in the house, right? And so as the temperature goes down, which is negative over here, the energy use goes up. Or I should say it the other way. As the temperature outside increases, the energy use goes down, right? That's what we would expect. I think this curve is about what we would expect to see. But what I'm really curious is once we get below 32, right? What we've been talking about before, how the heat pumps kind of struggle once you get down into the very low 30s and the 20s and below. So that's what I really wanted to see on these graphs. Unfortunately, we had something wackadoodle happen in December. So let me just explain this really quickly. So this green bar right here is this green line is temperature outside. Okay. So in December, we had a bit of really cold days where the average temperature dipped below 30 degrees. Okay. So I'm like, okay, this is it. This is the moment I really get to see what's going on here. Well, unfortunately, on the 4th or 5th of December, we had some HVAC guys coming over and they changed our thermostat to a new smart thermostat that goes with our GE equipment. And I think what we believe what happened is they inadvertently turned on our electric resistance backup heat and turned off our heat pump over here.
They locked out the outdoor unit.
They locked out the outdoor unit for the original part of the house. So this dark green line is that outdoor unit, and you can see it goes down to pretty much almost nothing. And while the temperature dips down, this blue line is the indoor air handler, and it's going kind of crazy. And then in the meantime, it stops listening to the thermostat altogether. So we have days when the system wasn't working at all, and we couldn't quite figure that out. So a couple of interesting things. I'm glad we did this analysis. One, we learned that the electric resistance backup heat was turning on when it shouldn't, and it was caught huge amounts. I mean, this is one day we had over 90 kilowatt hours, this spike right here, right? And number two, I mean, obviously it's not communicating well with the thermostat because we really didn't, we didn't want to be freezing on these different days. Which we knew in the house it wasn't quite right, but because we have so many systems, this is like I guess it's the silver lining sort of. If one system goes out, we were okay. We weren't totally freezing in here because we have, 3 other mini splits that were taking care of it and doing their job. This is what it looks like, that same type of chart where you look at outdoor temperature versus energy use. And again, I can't really use this data anywhere because this guy up here is the electric resistance backup heat. It's not the heat pump. So unfortunately, we can't, but we're going to get better data in January. And then this is interesting. The blue line is November. The orange line is the wacky December. And I have this little box drawn around here because I was showing my HVAC guy that even though we were in similar temperatures here, that we were using way too much energy, right? So that's the heat pumps not working. I think that's our last slide, isn't it? Yeah, we had one that we just want to thank our sponsors for the project that we're working on right now. But darn, I'm so sorry. We're like out of time, but do we have like, Kara, can we take like a couple of quick questions or?
Yeah. Oh, it's down.
Anybody? Matt, do you have anything to add? We're out of time.
I've got a quick
Jim?
question just in terms of, oh, sorry. Hi, just thank you for the overview. Everything or the presentation was great. The training was great. Just in terms of the clients that you work with, are you finding that most of them seem fairly well informed about the economic benefits of heat pump upgrades, or is there an education that you're also delivering to some prospective clients?
Yeah, a lot of education, I would say. I mean, most people come to us because they have, a comfort issue or their equipment is old or they really want to build on that new primary suite or something, They're not necessarily coming to us and saying, "Hey, I want to decarbonize." And I mean, sometimes it happens, We have one client who has shared the Nobel Peace Prize for climate change with Al Gore. He's a great guy. He lives in Arlington. He totally got it, and he got his house to net zero, but that's still pretty rare.
So I guess it comes down to cost and comfort, as you've been iterating throughout
Yeah, and
training.
really, if I could do a better job of showing them the data up front, we just don't have enough data. I've just started, doing this data analysis and really understanding what it means. I think if I could show them that cost benefit, I don't know, Jeremy, if you have success doing that, but show it to them up front, then we would have an easier sale for sure.
I think it's all, at least from a customer's point of view, fairly theoretical unless you're able to work with them and look at their utility bills and really apply that to where upgrades of a similar size property have worked.
Hmm.
That's the part that I've had some difficulty in.
Hmm. Yeah, we need more
I'm
data.
one, I'm I I'm the customer side that we our air conditioning went out on us and we had to get we had to replace it and we did all this research on heat pumps and everything and then I I'm scared to s- ask the question because I have seven mini splits and it's it's Mitsubishi and we did it with a diamond contractor for that and I just we've had like our electric bill double and the past 2 months and so it's really interesting this presentation because I see that I need to do some similar kind of analysis on our place, but and we also installed solar so in August. So it's yeah.
So
So thank
your
you for the
elect
presentation.
Oh no, thank you too. I'd love to talk to you offline, Christy, but so your electric bill has doubled despite the fact that you're now using solar? I mean, with the solar?
Um yeah. It went to $592 and it's like we live in a I mean we've done like the energy audit we've gone to induction we disconnected from the gas so we're we're kind of shocked like this is the first 2 months cold months that we've had to endure so um anyway so yeah.
Yeah, let's talk some more about it because I am very curious. And we can figure out ways of, there are monitors that you can attach to your panel. If you don't have a smart panel, you can make it a smart panel by putting, there's different tools you can use. So that might be an interesting thing to do to sort of really try to get an accurate read on that.
Yep. And we're having the installer, the heat pump installer over today. So maybe we'll get some answers from that as well. So thank you.
Do you have an ERV or anything running in the house?
And
Any,
ER,
yeah, anything like fresh air ventilator, anything bringing fresh air into the house?
No.
No, okay. Because we have found too, another issue is with these ERVs or any fresh air ventilator, sometimes when it's really cold out, it's bringing cold air into the house. It's supposed to exchange energy with the air that's going out of the house, but it can only recover so much, right? So on a really cold day, we find that these ventilators are fighting our HVAC equipment, which
Mhm.
also, makes them less efficient.
Yeah, and I mean, I heard you talking about auxiliary systems, and we haven't looked into any of those. So, I'm interested in looking into what we might need to do in addition to the heat pumps. So,
Mhm.
anyway, thanks.
Kara, any other final questions or thoughts?
No other questions in the chat. I think we're
Good.
all set.
All right. Well, I want to say thank you to everybody for joining us today. And I think there will be an evaluation that goes out. We'd love feedback and we'd love to hear from you individually. There's my contact information on the slide. Yeah. Anything final?
Yeah, thanks, everybody.
All right.
Thank you.
Thank you.
Appreciate it.
Thank you all.
Thank you.
Thank you.